Hey everyone, welcome to my channel. In this video, we are going to learn how to apply virtual zoom to an image using gesture recognition. We will first look at multiple hand tracking and then apply the zoom gesture. And don't worry, we will write the code step by step to make the tutorial beginner friendly. If you would like to level up your computer vision skills, do check out our premium courses. For the first time ever, we have a computer vision with Arduino course available now for pre-order. The links are in the description below. So without further ado, let's get started. So here we are in our PyCharm project and we have the project called Virtual Zoom, and we will go to File, Settings, and here in the Projects Python interpreter we are going to add. And here we are going to add CVZone. We will hit install and then we are going to go and install media pipe, and we are going to hit install package. So these are the two packages that we need, and at the back end it installs a lot of different libraries as well. So for example, matplotlib, it installs Pillow, it installs OpenCV Python, which is the backends, which is the main library that we are using. So all of these are dependencies that are automatically installed. So we are going to install these, and the first thing we will do, this is the main file that is automatically generated. We are going to remove that and we will write here import CV2, and we are going to say from CVZone dot hand tracking module import hand detector. So we are going to use the hand detector in this project, so we will import that. Now here you can see we have an image cvarduino.jpg. This is basically our upcoming course, computer vision with Arduino. It's a very small image at this point because we are going to overlay it on another image and we are going to zoom in and out. So we wanted a small image to work with to see if it works properly. Now, if you haven't checked it out, do check out this computer vision course in the description below. This is the first course of its kind, which is a combination of computer vision and Arduino. It will allow you to create real world applications that you can use it in your home, in industry, and so on. So anyways, so the idea here is that we are going to create an object first. Cap is equals to cv2 dot video capture. And we are going to add our ID number, and this time around we are going to set the size. So the width will be 1280 and cap.set the height will be 720. So this is so that we have a bigger area and we can play around with the zoom. And then we are going to write while true, we are going to say success and image is equals to cap.read and then cv2.imshow, not cv3, cv2.imshow, and then we are going to write image and img and cv2.wait key, and we are going to give a delay of 1 millisecond. So let's see if this works properly so far. So we are going to run the main file, and hopefully you will see me sitting on my chair in front of my computer, and that is not the case. Cap, okay. Cap.set, my bad. Cap.set. Okay, so let's see. And there you go. So now our webcam is working, and we are going to move ahead and create a detector. So here we are going to write detector is equals to hand detector, and we are going to give the detection confidence as 0.8 and the maximum hands as 2, which is by default, so we don't need to give that. Anyways, so this is the idea, and then we simply have to write hands and image is equals to detector dot find hands, and that is pretty much it. So it will give us the hands, which contains the list of hands, and each hand will have information of the landmarks, information of the bounding box, the center and the hand type. So if it's a left hand or a right hand, in this case, we don't really care, but still it is good to have that information. So right now we can simply play it and it should give us all this information and it will display it on the screen. So let's see if it works properly so we can move further. So here is my right hand and here is my left hand, and you can see it is working fine. So what we can do now is, first of all, the idea is to import this image. So we are going to write here image1 is equals to cv2.imread, and we are going to give in our cv arduino.jpg. Now, in order to put this image somewhere on our main image, all we have to do is we have to write image, and within the brackets we have to slice it. This is called slicing. So here we are going to slice the height and then we are going to slice the width. So let's say we are slicing from 0 till 250, because right now the size of this image is 250 by 250. So right now we are hard coding, we are giving static values, but later on we are going to make it dynamic so it works automatically. So then we are also going to give the width of 250, and in this portion, in this region, we want it to be image 1. So this will overlay our image. So let's see if that works. There you go. So on the left hand side you can see we have our image and it is working fine. So now if you wanted to shift it, you cannot just write 10 here if you wanted to shift it by 10. So if you increase the value here, you have to increase the value here as well. So you have to write, let's say, 260. And here, if you're doing 10, again, you have to write 260. So if I run this now, you will see that now the image will be a little bit shifted down and forward, both in the X and the Y. So here you can see it is a little bit shifted. So that is how you can overlay an image. But now we want to zoom in and out. We want to increase the size and decrease the size of this image. So how can we do that? First of all, we need a gesture by which we are going to do this. So we are going to first check that if our length of hands, now we are going to use 2 hands for our gesture. Now, if you want to use 1 hand, you can use that too. But since we have already done projects with single hand, like the volume control and the virtual mouse, so we are going to use 2 hands for this case. So length of hands is equals to 2. Then we are going to say, let's say, any gesture. Let's say print zoom gesture. So let's see if that works. So I bring in 1 hand, doesn't happen. I bring in the second one and it says zoom gesture. So this is exactly what we want. We want it to give us a feedback whenever we have 2 hands ready. Okay, so then we need to find the gesture through which we are going to zoom in and out. So we need to find how many fingers are up. So let me show you what gesture am I planning to use so that it will be easier to see when we are coding. So here we have 5 fingers. Again, we have 5 fingers. So the gesture I'm planning to do is basically this over here. So this basically is like you're taking a shot. So I don't know, it's a director's cut or something. So normally when you see somebody doing this, it can relate to zoom in and out. If you wanted, you could do it like this. It's up to you. If you wanted, you can do it like this. Up to you. But I'm going to do it like this. So let's see if that will work properly. So what exactly do I have to do? I have to make sure this finger and this finger, the thumb and the index finger, they are up. The rest of them, they are down. And the same thing over here. So I need to check for both of them if they are up, if 2 of them are up and the rest of them are down. So how can I check that? We can write here detector dot fingers up, and we need to find the fingers up of hand number 1. So we will write here hands at 0. So it will give us that information. And then we can also write detector dot find hands, not find hands, fingers up, and we are going to write hands at 1. So this will give us that information. So let's just print it and see if it works, and then we can use it with an if statement. So let's bring in both our hands, and there you go. So okay, the zoom gesture is annoying because multiple prints. Then we can play it again. So the idea is that it will give us 2 lists, and each list will contain 5 values. So we will have a total of 10 values with 0 or 1. So 1 means that it is up, and 0 means that it is down. So here you can see both thumbs are up, and then here you can see both index are up. So we need to get this 11000, 11000. So this is the value that we need. So how can we check that? We can simply write here, we can copy this part, and we can write here, if this is equals to, we will give in 1 1 1 1 and 0 0 0. So if this is equals to this list, and this is also equals to this. Going a little bit further, we can push it down. If that is the case, then we need to put a slash here, otherwise it will not know it's continuing. So then what we will do is we will write here print zoom gesture. Let's just copy it from here. Zoom gesture, we are going to remove it from here. Oh, there you go. So whenever now I have my index and thumb up for both my hands, it should tell us zoom gesture. Otherwise, it should not. So there you go. Right now it's saying zoom gesture. If I put even one out, or if I have one of them down, it will not work. All of them have to be up to work properly. These have to be down. These have to be down. And then these have to be up. So then it's giving us the zoom gesture. So this is perfect in our case because we have reached the correct point. And now what we will do is we will find the distance between these two hands. Now you can find the distance between the tips, or you can find the distance between the center points. It's up to you. Here we are going to use the tip of the index fingers. So what we will do is, first of all, let's just remove this, because it will be annoying. And should we remove this? Let's just remove that as well, because we already know that. Okay, so what we will do is, first of all, we will get the landmark list of hand number 1, which will be hands at 0, and we are going to request the LM list. L here is capital, just make sure you know that. And then we will paste it down here, and we are going to write here LM list 2, and the hands is also 1. So this will give us the list of 1, the first hand, and the list of the second hand. Now the point number 8 is basically the tip of the finger, the tip of the index finger. So we need to check the distance between the tip of the index finger of the left hand and the tip of the index finger of the right hand. So I will write here point 8 is the tip of the index finger. So we need to find the distance between LM list 1 at point 8 and LM list 2 at point 8. So the tip of the both index fingers. So what we can do is we can write here that detector dot find distance, and we will write here LM list 1 at 8 and then LM list 2 at 8. And we want to draw it, so we will give in our image back. We will send in our image, and we will also receive the image. We will write here length, length, and we will write that info, and also we have our image back is equals to this. So these are the parameters, these are the variables that we will get back. So that is good. Now we will get the length. So we can print here, print length. And now let's check it out. So there you go. So once I do this, you will see the length. If I remove that, you will see it doesn't work. So it has to be this gesture. And now it is telling me the distance of this point. Now the thing is, when we start, let's say this is my starting point. So this is my origin, right? Now, if I go outwards from here, it should zoom out. It should increase the zoom. If I go back from here, it should decrease, zoom out, right? So what we have to do is we have to make sure that we know the center value, the starting value. So here, the starting value is nothing. When I do this, the first value that it gets of the length is our 0 point. So from there, if it goes beyond, we will zoom further. If it goes smaller, we will shrink our image. So this is basically the idea. So what we have to do is we will create a variable here, and we are going to call it start distance is equals to none. We don't want to give it a value, and I will tell you why. Then we will check first. If our start distance is none, then we are going to find this. And once we find that initial length value, we are going to say that the start distance is equals to the length value. And now what I can do is I can simply find this for each iteration. I will find this value, the length value for each iteration, and I will subtract my start distance from it. So I can say, let's say my scale is equals to the start distance minus the length. So if I'm increasing, it will give me a bigger value, positive value. So it means we need to zoom in further. If it gives me a negative value, it means we need to shrink the image. So let's, instead of printing length, let's just print the scale. The scale might not be the best name for this, but anyways, we can change the name later on as well. So let's try that out. Okay, so when I do that, you will see it's already giving me minus. If I go, if I go closer, it's giving me positive. Okay, we need to make it the other way around. So length minus start distance. My bad. Let's run that again. So when we increase the distance, it should zoom in. When we decrease the distance, it should zoom out. So let's see that. So here, negative value increases, positive value increases. There you go. If I close, then now wherever I start, that is the starting point. So what we need to do is we need to reset the value whenever we lose the hands, because it's using the same old value. So we will say that else, if two hands are not detected, then the distance is equals to none. So go back to the distance none. So now whenever we reset, the values should be closer to 0. So let's see here. So there you go. So if I start again, it is, well, it's closer. It's not exactly at 0. But you can see, because there is a little bit of variation every now and then. There you go. So it is a little bit closer to 0. Anyways, so this is basically the idea. And now that this is working fine, the next step we have to do is we have to send this scale value to our image so that it can make it bigger or smaller. So, and once we have that, it should be good to go. Now, one more thing we need over here is the center points of our distance. So if we look at our find distance, it gives us in the info, it gives us the center X and the center Y, this value, because we want our image to be exactly in the center of both of our hands. So here what we can do is we can get the information. So we can write here CX and CY is equals to info at 4 and 5. So instead of writing 4 and 5, I can write it like this, 4 till the end, because we know that it is the end. There's nothing after 5, so we can write it like this. So this is basically the idea. Now, one more thing we will do is we will decrease the sensitivity of this because we are getting big values like 200, 300. We don't want it to increase dramatically. So what we can do is we can divide it by 2. We can make it an integer and we can divide it by 2. Divide it by 2. There you go. Just to make sure it is a whole number. Okay, so that is pretty much it. And now we need to go to the last part, which is actually to zoom in and out. Now, this is a tricky one because when you are changing the size of the image and there are decimal places involved, then it can be problematic. And once you want to center it, then you might get an odd value and it is not divisible by 2. You will get decimal places, and then your the size will be different for the image and the scaling, and it will not go on the other image properly. So what we will do is we will have a little bit of trick here, but let's start with it first. First of all, what we need is the size of our image right now. So we will write here that our h1, width 1, and our channel we can ignore is equals to image1 dot shape. So this is our shape at this point of image 1. So the one that we got, which will be 250 and 250 at the starting point, right? So now we need the new width and the height. So we will write here new height and new width, and that will be h1 plus our scale, right? So that is the scale that we are using here. We will do that. And then it will be h1, not h1, w1 plus the scale. So that is basically the idea. And then we will resize our old image. So we will write here image1 is equals to cv2 dot resize, cv2 dot resize, and the source will be image1, and the value will be new width and the new height. So that is our value. And now what we need to do is we need to change these values to make it dynamic. So what we will do is this value we are going to add here. So, but we want it to be in the center of our both hands. So the center of CX and CY. So our starting point will be CX. Actually, this one is the height. So it will be CY and CX. And then it is not just that, because this will be the corner point. We want the image to be in the center of this origin. So we will write here CX minus our new height divided by 2. And then the same thing we are going to write here, but instead of minus, we will write here plus. CY plus new height divided by 2. And the same thing will happen for our width. So we will write here CX, and we will write here new width, and then we will write CX and we will write new width. So this will update the value right in the center of our hands, and it will shift it according to the center position. And it will already have our scale value. So let's run that and see what happens. Scale is not defined. Okay, so initially we need to define scale. Scale is equals to 0. So let's go ahead and see if it works now. Okay, CX and CY. Yes, we didn't define those as well. So CX and CY, they are being declared here for the first time. So that is not right. So we need to define here first CX and CY is equals to, let's say, 500 and 500. Just randomly in the center of the image. There we go. So here we have our image. And now if I do this, you saw the image is moving, but here is the big issue. The big issue is that the image size is 275, but then when we are putting it here, it becomes 274. Now, where did this 1 pixel go? Now, this is something that is a little bit tricky to understand. The problem here, what we are facing, is that when we divide this by 2 and we make it an integer value or a whole number, then it might actually lose its original value when we multiply it by 2 again. So here, if it becomes, let's say if the value was 99, then if you divide it by 2, it will become 49.5. And then it will make it a whole number, so it will become 49. So when we multiply it by 2 again, it will be 49 plus 49, and that will give you 98 instead of 99. So this is our issue. So what we have to do is we have to make sure that these two values are exactly the same, otherwise it will not work. So what we will do is we will make sure that our value of the new height and the new width is divisible by 2. So how can we make sure of that? We can simply divide this by 2, and then it will give, let's say, a decimal place, and then we can simply multiply it by 2 again, and then it will make sure that the next time when we divide it, it is a whole number and it is divisible by 2. So we will lose 1 pixel, but it's okay. So we will divide it by 2, and then we will multiply it by 2. There you go. So if we run this now, hopefully this should work. There you go. And there you have it. So now you can see if I move my hand around, it is zooming in and out based on my hand. If I remove, it will stay there. So if I grab the image and I move it around, let's say over here, I make it bigger. The hands need to be inside the image, otherwise it will not work. So if I zoom in and if I leave it there, it will stay there. Then I need to do this again, and then I can push it down, let's say over here. But then if I go too below, it gives me an error because there's no space in the image. So you can write some fancy lines to actually fix that, to draw even the half part. But instead of doing that, we are going to simply write try and accept because we are lazy. Accept, and we are going to write here pass. So if it goes above or beyond, then this time around, it will not show us the image. It will just disappear, and this part of the code will not work. So if I zoom in too much, if I go above, nothing will happen. If I come back down, it will start working again. Same thing if I go down too low, the same thing will happen. My mic is coming in between, and even the fingers, they disappear. So it is a little bit tough at the bottom side. But as you can see, you can get the idea of how you can zoom in. So this is basically the idea of how you can zoom in and out. As you can see, it is quite smooth. It is real time. We don't have any issues. Sometimes my hand comes behind the mic and it doesn't detect properly, but otherwise it seems quite fluent. And also what you can do is, if you wanted to do it with the center of the hand instead of the tip of the fingers, then we can get the information from here. So what you can do is you can write here instead of the landmark list, you can write here that hands at 0, and then I need the center, and that is pretty much it. So this is for the hands 0, and this one will be for hands 1. So I will remove this one and I will copy this and I will paste it here, and I will remove this one. So this time around it will check the center of the hand instead of the tip of the index, but it will still require you to have both the index and the thumb up. So there you go. So now it's in the middle of the the center of the hands rather than the tip of the fingers. So you can see the distance. I can make it really small and then it goes big again. I can remove it, let's make it small again. There you go. Looks quite good. So this is basically the idea of how you can use zoom in, virtual zoom in functionality using CVZone, MediaPipe, and OpenCV. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up. If you really like it, share it with your friends, and do comments. What projects would you like to see next? So this is it for today, and I will see you in the next one.